I lied previously. Water, or H2O, it actually exists as H plus or hydrogen cations and OH negative anions. It's almost as if Mickey Mouse here did like a Van Gogh move and chopped its ear off. The ear, or the hydrogen, leaves with its proton, but not with its electron. Remember, hydrogen's electron is attracted to anything else but its corresponding proton. The OH part leaves with all of the electrons from the water molecule, making it an anion because it has one extra electron. H plus cations will be incredibly significant for us in this class because these are what the pH scale measures. pH is not a measurement of acidity. It's more of a measurement of the ratio of H plus cations to OH negative anions. When they're in proportion of twice as many hydrogen as OH anions, then we have water. The problem is that your body makes H plus cations all day long. No, it does not make the corresponding OH negative anions, just those H plus cations. And this tips that balance or proportion of H plus to OH negative, making the cations outweigh the anions. And since pH is a measurement of that proportion, the number pH changes as well. This picture here is the pH scale. And I want to point out that this is a man-made scale. I mean, we needed some way to quantify pH, and so somebody came up with an equation, and this scale is it. The pH scale ranges from 0 to 14. And it doesn't matter, I have some pH scale pictures where 0's at the bottom of the picture, 14's at the top. I even have one where the pH scale is horizontal. It doesn't matter. It ranges from 0 to 14. And the numbers, they all indicate something about the proportion of H plus cations to OH negative anions. In the pictures on the right, you can see those proportions of the H plus cations that are in red and the OH negative anions that are in purple. Let's start at the midpoint of the pH scale, which is a pH of 7, or is a pH that is neutral. This means that the number of H plus cations equals the numbers of OH negative anions. No, it does not mean that there are 7 cations and 7 anions. In fact, the 7 is the result of a logarithmic equation that I beg you we not concern ourselves with here in this class. So basically, water has a neutral pH, and blood is just a little bit higher than that, with a pH that comes in at 7.35 to 7.45. All right, let's first consider acidic substances. These are substances that have a value of 0 to 7 on the pH scale. These are substances that have an excess of OH cations an excess of H plus cations compared to the OH negative anions. And these are things such as orange juice, the love of my life, coffee, not my husband, and other non-consumables such as battery acid, which actually has a pH that is very close to the pH that is in your stomach. Oh, and heartburn is the over-acidity of your stomach contents, as well as the burping up of those contents, but that's for another lecture. I once had a student ask me what was the pH of the most acidic thing on Earth, and I said 0. I proclaimed it, actually. But then he asked what would happen if we discovered something that was more acidic than that. And I said that we'd probably rearrange the logarithmic scale or the logarithmic equation so that the new substance was pH was 0. And he replied that that was cheating. Yes, but that's also science. We have to adjust our technology and our measurements for new discoveries. So if acidity means that you have excess H plus cations and you are making excess H plus cations all day long without making the corresponding OH negative anions, then your blood becomes acidic throughout the course of the day. Your negative feedback mechanisms are reversing that change to keep your blood within the correct pH range. Complicating this is also the fact that carbon dioxide is acidic, and you make that all day long too. Your life is basically a big battle to keep from being acidic. But don't worry, it's not just humans that do this. It's pretty much all living things. We are not unique in that sense. So we have a feel for acidity. It's the values on the pH scale, the proportion of the H plus cations to the OH negative anions, and the fact that you are drawn to that part of the pH scale daily. The values of 7 to 14 on the pH scale reflect alkalinity, which we can also call basic, not acidic. You can use either term in this class. If you take a chem class, you might have a professor that forces you to use one or the other. So these values of 7 to 14 on the pH scale indicate that there are less hydrogen cations than the OH negative anions. And this scale, this part of the scale reflects things like Tums, Rolaids. What other medications can you think of for heartburn? Oh, blue cheese, which is neutral because you pair it with those hot, spicy, and acidic wings. Powerful cleaners such as bleach and ammonia also fall on this range of the scale. We don't deal with alkalinity in the human body nearly as much as we deal with acidity. Thankfully, there are substances in your blood that are called buffers, and buffers resist a change in pH by absorbing or bonding with the excess H plus cations or the excess OH negative anions. If your blood is acidic, there are substances that can bond with those excess cations and anions. Excess cations, raising your blood's pH. These are buffers that are not only helping to resist change, but also helping to bring it back into the correct range when it leaves that range. There are many proteins that act as buffers against acidity in your blood, and that's good because you tend to go acidic during the day. You have buffers that also resist increasing pH changes, but there's not nearly as many because your blood does not tend to go basic or alkaline. The bicarbonate anion is one anion that is very important to know in this class. This is HCO3, and the negative indicates that it's an anion. It is made using the carbon dioxide that your cells make in cellular respiration. You might also know of sodium bicarbonate, which is baking soda. Bicarbonate is a blood buffer, and it has an almost limitless supply since you make it all day long. This is great because you're making those acidic cations all day long too, and the alkaline bicarb anions bond with those acidic H plus cations, removing their effect on your blood pH. Yeah, but what happens if all the buffers in your blood are occupied, but you're still acidic? Well, your lungs and your kidneys, they also play a part in managing your pH, but they don't like to do anything unless or until all of the buffers in your blood are exhausted. Remember I said that carbon dioxide is acidic? Well, if your blood is too acidic, your breathing rate will increase, trying to blow off that carbon dioxide that you're making. If your blood is too basic, your respiratory rate will decrease as your body tries to hold in that acidic carbon dioxide and adjust your pH. If your lungs are not able to have the effect and the desired change in pH, then the kidney will reluctantly kick in and try to manage those H+ cations for you by excreting them in your urine.